Okay. Hi, I'm Mina. I was a program committee chair. I'm from University of Waterloo. So I'm also going to be quick. First of all, I want to start with thanking everybody who submitted to the workshop. Without you, we wouldn't have this kind of nice program ahead of us. We had 4 different presentation modes. We had in-depth talks, lightning talks, posters, and demos. We got 29 submissions, and each of them received 3 reviews. And we were able to accept all of them but 2, which is something we're very happy about because P4 is growing into this broad and vibrant community. So we're very excited that we can kind of hear from everybody who's been working on P4 applications, the P4 language itself, or the ecosystem around it. And just a very big thank you to the amazing program committee that put in a lot of effort in making sure kind of the papers get good reviews, submissions get good reviews. And kind of putting together a great program for you. Without them, this wouldn't have been possible. And with that, Andy, on to you. Yep.
So let's see. My goal is I'm looking forward to those really good keynotes later. This one's going to be average, I think. So I just want to remind folks, if anybody's wondering, I in my role at Intel, there's a recent announcement that a lot of people have heard of that I'm not going to describe in any more detail. But P4's reason for being is the same as it was before that announcement and after that announcement. My full-time job is still working with P4, talking to people, engineers at Intel, talking to customers, potential customers of Intel. And the reason for being, the raison d'etre, is the same as it was. It's describing packet processing, either functionally describing it or, more commonly, programming a device in that language. Why? Why not C? Why not other languages? There's plenty of other programming languages that are perfectly great for general purpose CPUs. But the hardware architectures that have the best price/power/performance ratios for this category of processing, packet processing, have hardware architectures that are not really good targets for C or other general purpose programming languages. The match action pipeline in its various hardware incarnations is the best we know how to build. If you talk to any hardware architects at any of the companies, any of the vendors, and you tell them, can you just give me a bunch of general purpose CPUs? There's a few targets that do that, but they tend to be higher on the power, higher in the price, performance ratios than things like the RMT architecture or the DRMT architecture. So until somebody comes up with a better hardware architecture that can do these kinds of things, better price, power, performance ratios, P4 is a great choice. If P4 didn't exist, I would reinvent it. Somebody else would reinvent it, or something very much like it. So that's like a negative way of saying it. But I mean, people have Gordon Brebner at Xilinx, then at Xilinx, invented a language something like this. I've seen within Cisco over the past 20 years, people inventing languages for specific network processor hardware, and it was never published out to the world or evangelized because it was meant for that target. And it was great for that, but it was used only by Cisco engineers. So P4 is the first thing I've seen that's been evangelized and accepted by a community in the way that it has for this feature set. So shorter way of saying that, P4 is the de facto standard for this purpose. Other notes that I've wished I would have put in the slide, but Nate Foster did some collecting of statistics that I'll mention just in the academic research community. At the 2022 SIGCOMM conference last fall, 29% of papers used P4 in some way. Either they had a prototype implemented in it, or they based their work upon it in some other way. And also in the academic community, there's been P4 courses. I don't know which years all of these were, but some of them older, some of them more recent, at Cornell, Stanford, Yale, Princeton, Waterloo, ETH Zurich, and a few more. So P4's reason for being is the same as it always has been. And now in my work as an engineer and working on the various P4.org working groups, I always see and hear from customers, potential customers, things that are missing. So my work tends to be 80%. What's missing? What do we do about it? So I see missing features all the time, and then the question is what to do about it. And my answer is usually, what can we do incrementally to improve the language, add things to the language, preferably in a backwards compatible way so that all the existing programs keep meaning the same thing as before, so that we can do these new features, and preferably in a way that multiple vendors can implement that So looking back a few years, some of these things I've said before, this is review really, but if it's new to you, great. Features that weren't in any p4.org spec 3 years ago were things like if you look up in a table in a miss and you want to add a new flow for that entry in the data plane without bothering the control plane, there was no standard way of doing that. You could hack up some things, but we worked in the portable NIC architecture working group in the last several years to define one way to express this in language so that it's something that multiple vendors can implement. Similarly, if you want to do add-on miss in the data plane, you're probably going to be adding millions of entries per second. You want to be able to usually age those out and delete them at millions of entries per second over time. On the average, you can't be adding more than you're deleting forever. So having mechanisms for not just idle timeout, but also when the timer expires, deleting the entry when it's done. Also the ability to, in a feature like TCP connection tracking, you want to not just set the idle timeout at the beginning, you want to be able to modify it. So maybe you're in this connection setup phase, you want one timeout value, 30 seconds. You get in the established phase, you want a 2-minute timeout, idle timeout, say, and then maybe when you see a fin or a reset, you want a shorter timeout again. So in the data plane, be able to adjust these timeouts and auto-delete the flow. Packet encryption and decryption is another feature we've worked on and have one proposed API for doing that in the portable NIC architecture spec today. So missing features today, this year, right now, or in process. So we've been working in the, this originated, the portable NIC architecture working group. Mario Baldi's group came forward with this feature, and I said, yeah, there are ways to do this, but they're kind of syntax-wise clunky. It'd be nice if there was another way to do it. So just the ability to have per entry table state where, I mean, what you're used to in P4 action parameters when you don't put it in, out, or in, out is that comes from the control plane, and the data plane can only read it. But what if there's another kind of parameter that the control plane initializes it, but the data plane can update it on every packet that executes that action? So things like updating expected sequence numbers in a TCP connection tracking application, but a whole host of other applications besides that. That's just a poster child application. So high throughput control plane APIs. Again, when you're talking switch ASICs, usually you're talking tens to hundreds of megabytes of table storage in the device when you're talking about a multi-terabyte device. But just about every NIC, smart NIC out there has one or more DRAM channels, DRAM devices sitting next to it for storing large tables. If you've got a 16 million entry table, you don't want to take an hour to load that thing up. So this is just a performance concern, but there are certain things in the P4 runtime API that could be tuned or optimized for the special case of adding a bunch of entries to the same table that could speed it up quite dramatically. And so in the P4 API working group, they've been evaluating alternatives for this recently. And then another thing that Intel has done with TDI is to try to make, in the P4 API working group, you can define an extern, but there's no standard way to define what's the control plane API for this. It's pretty much custom for each one. It's still custom for each one, but at least one proposal is that the style of it should look like one or more P4 tables as far as the control plane is concerned. So that's not a big revolutionary idea, but it's a nice incremental idea that I hope catches on. So all these things are under discussion in various P4.org working groups now, and hopefully will be completed before 6 months goes by, I hope. A few more things. So these may be a little, the first one's a little more speculative or more recent at least, but there's been work in research groups as well as at NVIDIA proposing, updating P4 code with 0 or very low packet forwarding downtime when you want to change the P4 program. So this one's probably most speculative or early, but I expect will be a hot topic for some time to come. There's support in Linux to load P4 programs into the kernel, and then if you have a smart NIC capable of supporting that P4 program, offloading that into the device with standard APIs from user space applications into the kernel for doing so. There's a P4TC talk later in this workshop, and then Wednesday there's an all-day workshop for people interested specifically on this topic, trying to push that forward. This is also quite early, but some engineers at Intel have been working on support for better IDE type support. So you could run VS Code, get all your standard, the kind of things you're used to with symbol completion highlighting we kind of already have, but the ability to get the outline view of see all your P4 tables and actions in a list, click on one, jump to that in the code, things like that. So lots of other stuff I'm sure that they're planning that's the one that I miss most when I program P4. So there's an early version of this in this public repo added recently, but they're still actively working on it. So don't expect it to be done right now, but keep an eye on it if you're interested. So of course, yes, my work is usually focused on P4 as a programming language, but there's a lot of people that use P4 as a specification language as well. As in, they don't want to program the device, they just want to write a P4 program that describes an existing device or the subset of features that they care about in an existing device, and then reason about that and do various either formal or testing-based methodology on that. I just wanted to mention, so the last year, an engineer at Intel, Fabian Ruffy, primarily, and Nate Foster, have been working on open sourcing a tool called P4 TestGen, which has gotten some interest from some of Intel's customers, and it's open source, so if you think it'll be useful, it can do some kind of formal verification things as well, or guided creation of guided automatic creation of test cases. But you can even put assert statements in there, and sometimes assert that certain things are true about your program, and it'll find a test case that violates it if your program violates it. So it can be used for some kinds of formal verification work as well. So as far as active participants, all of these companies I work with, all the ones with asterisks next to them, there's at least one of the p4.org working group co-chairs who works at that company, in some cases a couple. So I work with most of these folks every week or every month when we have meetings. Let's see. So yeah, active participation for all these, and most of these are either vendors of smart NIC devices, DPUs, IPUs, whichever marketing term wins, or customers that want to use these devices, buy many of these devices and deploy them. All right. I probably talked too fast. Now's the time for me to slow down and listen to if there are any questions. Please fire them away. All right. Oh, I thought he was going to ask a question. We just had somebody walk right by a microphone very slowly and expectantly. Yeah. So yeah, and please feel free to come up, and if you have any questions, feel free to come up to me in the hallway. That's one of the reasons you're at a physical conference for the first time in probably 3 years, like myself. Glad to be here. Glad to see a lot of familiar faces. Glad to see industry luminary Chris Summers, who's a new, this is an in-joke between the two of us where I think he picked this title for himself, and I get to use it several times a year to poke fun at him. Oh, I should mention, this might be mentioned in other talks, but Chris is agreed recently in the last month or so to become a co-chair for the p4.org API working group. Thank you very much, Chris. He's helped out in the past and had some good proposals, and now he's helping shepherd new things through there and discussions. Mario Baldi has become a co-chair, replacing Gordon Brebner of the architecture working group in the last year, I think it's been. So, we've got, I wanted to thank Antonin Boss for all of his, he was the co-chair of the P4 API working group for, I believe, 6 years, from 2016 until just recently when he stepped down. So I just wanted to, I should have made a slide of all the code that Antonin has committed to P4lang repos. I don't know if you've ever done this. I should publish it on an email list after this because he's almost like a one-man army on, except for P4C. I think he's contributed code to the P4C repo, but like there's some repos where it's like 90% of the code is contributed by him. And it's not a short list, it's like 10 of them. So thank you, Antonin, for all of your work. He's still continuing to work with it, but just not as a co-chair anymore. So, all right. All right.